This presentation was first given in April 2015 at the International Maritime Organization Symposium on Marine Geoengineering. This is the classic picture of the blue planet, but man has had a massive impact and significantly changed many things, including the amount of phytoplankton in the oceans, not to mention forests and desertification, all of which we suspect would have massively impacted the appearance of the planet. And although man had been causing significant changes over at least the past 8,000 years, such as the removal of the big animals in North Africa and the desertification of Mesopotamia as a result, the planet was still very healthy by comparison to current day standards. Think of it, if you like, as a healthy individual with 2 fully functioning lungs, and compare us now to an individual with perhaps 1 lung and maybe a damaged one at that. You can live, you can sit, you can move around, but you can't run. The resilience has been taken completely out of the system. Up until about 400 years ago, the changes that we caused had been well within the planet's capacity to adapt to. But then from the 1600s onwards, our shipbuilding skills improved so much that we were able to start major commercial whaling. And whale oil became one of the principal fuels to light the whole of Europe and the developing east coast of the United States. Over the next 400 years, we've systematically wiped out far more than 90% of the whale population. But the whales were absolutely vital to the health of the oceans, because by moving up and down the water column and by defecating, they recycled the nutrients that were vital to support the phytoplankton. And the phytoplankton support the entire food chain within the oceans. Ultimately, nearly all life being dependent on the sun and the photosynthesis that it enables. Without the nutrients available in the open oceans, there is no phytoplankton, and the entire ecological web collapses. This would have a visible effect on the planet, and as we can see here in this image, which shows the albedo of the planet, great open expanses of the ocean shown dark blue have very low albedos. This allows sunlight to penetrate deep into the oceans and cause warming. And the same can be seen here in this image of the chlorophyll concentration of the planet. Vast areas of our ocean have become effectively desert. But as well as reducing the overall amount of life on the planet, through burning hydrocarbon fuels and deforestation and soil mismanagement, we have released something like 40% more carbon dioxide and other greenhouse gases into the atmosphere. This is causing warming and acidification of the oceans and multiple feedback loops, which are leading towards runaway climate change and a melting of the polar ice caps. The only safe course for humanity and all other life on Earth is for us to, as quickly as possible, return to the atmospheric concentrations of CO2 that prevailed throughout the early part of the Holocene, i.e. a return to 280 to 300 parts per million from the 400 parts per million and rising that we are at now. The only mechanism that exists that can do this to scale, and has of course done it very effectively over the millennia, is the biosphere, the carbon in all living things. Now the good news, if you can call it that, in reducing the total amount of living things on Earth to less than 50% of what they once were, is that we know the planet can support vastly more life. All that is required is a growth medium, nutrients, and sunlight. And as those dark blue and purple patches of the ocean show in this diagram, our oceans can provide just that. Now, unfortunately, it's not possible to breed thousands of whales and return them to the ocean within the timescale we have left available. And in any case, the food source for them does not exist. What is required is to rebuild the ocean ecology from the surface waters and down into the depths. As can be seen in this image, we know that the addition of nutrients will cause phytoplankton blooms. This is Iceland with a phytoplankton bloom caused by volcanic fallout. The same occurs with dust storms coming off the African desert. But the problem with this is that delivery is short term, and therefore one gets a bloom, and then as the nutrient supply runs out, the bloom dies before a complete ecosystem can establish. This image shows a variety of zooplankton and phytoplankton, small plants fed upon by herbivores, who in turn are fed upon by the small carnivores in the food chain above them. But it's the phytoplankton that drive the whole system and carry out the photosynthesis, which produces 50% of our oxygen. What is required is a long-term availability of the key nutrients in order to support these complex ecosystems and ensure that they can survive. And here our partner, Sev Clarke, an independent scientist working in Australia, has come up with a viable solution. His proposition is that we should use waste materials to create small, buoyant flakes which float on the surface of the ocean, slowly delivering micronutrients. The flakes will be made out of rice husks, which include silica, and mineral tailings rich in iron ore, silica, phosphorus, and other trace elements, all glued together with hot melt lignin, and then compressed into tiny flakes, each of which will float on the ocean surface for 6 to 12 months, providing the nutrients and a miniature habitat for the microorganisms that will depend upon them. This is a whole new science that we are going to have to learn, and quickly, as each area of the ocean will require a slightly different mix of nutrients, and the flakes will need to be delivered at varying times of the year. The flakes can even be adapted to help deal with the release of methane in the Arctic oceans. In this instance, there are microorganisms called methanotropes, methane-eating organisms, which need a supply of tungsten complemented by copper, nickel, iron and cobalt in order to form their bodies. The flakes will be dispersed over the open oceans by spraying them high into the air so that the wind distributes them widely across the surface. The beauty of Sev Clarke's proposal is that this should be a commercially viable operation. The waste materials used in making the flakes will themselves give those waste materials a value. By monitoring the development of the phytoplankton blooms from space, it should be possible to set up fishing licensing agreements, because under those phytoplankton blooms, huge fish stocks will develop. Fortunately, there's a new NASA mission recently announced, which is going to put a satellite into space designed to do just that by measuring the albedo of the ocean's surface waters. For every ton of iron in the buoyant flake fertilizer, and assuming about 80% losses, we're anticipating something like 6,000 tons of dry weight fish will be created. The flakes themselves may be produced and disseminated for as little as $84 a ton. This could result in the world's single largest generator of carbon credits. Our very conservative estimates of the cost of generating those carbon credits is about $10 per ton for each ton of carbon drawn down. The benefits of this process are progressive ocean deacidification once we've taken flake distribution to global scale, rapid reductions in the overall atmospheric greenhouse gas pollution, and a progressive return to more favourable atmospheric makeup. Increase in the carbon flux to the middle and deep ocean depths with the consequential carbon sequestration of 6 to 13 gigatons per year. But most importantly, when the project is launched and the oceans have been restored, there will be a massive growth in the amount of marine biomass, with the potential for an early drawdown in the region of 50 to maybe 100 gigatons as we rebuild the size of the Earth's total biosphere. Net increases in fish catch will provide protein for a large proportion of the world's population. Increases in the albedo of the fertilized ocean plumes will reflect away some of the sun's rays, helping to reduce the planet's temperature. And the new phytoplankton themselves will be producing diethyl sulfide, the gas that is given off and gives the sea its distinctive sea air feel. But it's these particles that create the nuclei that form marine clouds. And those marine clouds will also reflect away some of the sun's energy, further cooling the planet. So now what needs to be done? Right now, we're talking concepts. There's a huge amount of study work to be done, from initial proof of concept, followed by the obtaining of agreements, leading to small-scale approved sea trials and Earth system modelling, the outcome of which will lead to progressively larger trials in the different ocean locations. One of the first areas proposed for ocean trials is off the Mayakoya Islands in the Indian Ocean. This deep water location has the advantage of having a recycling current, which will allow an area of ocean to be treated with buoyant flakes, and then those flakes to be tracked, and the phytoplankton bloom and subsequent development of the entire marine ecology to be studied. Although ocean fertilization by buoyant flakes will not be a complete solution for atmospheric and ocean restoration, it is likely to be by far the most effective tool we have for carbon drawdown. When coupled with a rigorous program of conversion to renewable energy, reforestation and soil restoration, it does provide us with a realistic prospect of maintaining planet's temperatures below 1.5 degrees centigrade of warming, and offer the further opportunity of returning to the temperature ranges of the Holocene. This is a system of carbon drawdown that we know has the capacity to work and is well within the capability of our existing technologies. It is comparatively extremely inexpensive to deploy. Indeed, it has the potential to be profitable. Right now, our objective is to find financing and institutions that are prepared to get involved in the implementation of this most vital project. Further details can be found on the Envisionation website, or please feel free to call me or email either myself, Brew Pierce, or Sev Clark directly with any feedback you have to offer.